Hi there, and welcome back to Triplicate, and today we are going to talk about these little guys. These can be bought for a few pounds off eBay, and that is an FTDI USB to serial chip. So all you need to do is take a USB lead and plug it in this end, and out of this end we get serial, UART, ordinary UART serial, just RX and TX. To that you can connect, for instance, this, which is the GPS module used for the boat speedometer project, and this is the FTDI I'm using on that project as well. So that enables you to put USB onto a project without having to get around the complexities of the USB stack. Hi there, Editor here from Time Warp from the end of the video when I was putting it together. I realised that some of you watching this might just want to fire up an FTDI chip through the API using C++ Builder and don't want to watch 20 minutes of me humming and hawing, and if this is you, I will put a sort of bullet point summary of what I've done in the description, but please watch the video anyway, you might enjoy it. Right, back to the present. Okay, so here we are at the PC end, and how do we talk to our FTDI chip from the PC end? Well, there we go. There it is, COM port 6. So all we need to do is read and write from COM port 6, open COM port 6 and read and write from it in our software, which is easy enough, and that's what we're doing. But this is not without its little problems. I was prompted to make this video during the recent video we made on the heresy, the radical synth. So rebuilt the turntable as it is now, very happy with it, plugged it all in, fired it up, and it didn't work properly. And I'll show you why. Okay, so we fire up the software and it won't open the COM port. Why won't it open the COM port? Because I have been using other FTDIs and doing other serial things, and having plugged this FTDI back in again, it's now on COM port 5. We just have to change the COM port to COM port 5 in the code, so let's give that a go. So if we run it, open COM 5. So it's all going okay, but once you've got it fired up you'll get this. Why is it doing that? So why is it doing that? Well, this has cost me a little bit of time figuring this one out. If we go into port settings, so this in the middle, advanced, there we go, we look at USB transfer sizes and it says 4096 here. So what's happening, it's waiting. The heresy is just sending data out all the time. It's 8 bytes every 3 milliseconds saying the state of the turntable and the strings. But what it's doing is it's sitting with them in a buffer, a 4096 byte buffer, and if you ask to read while that buffer's filling, it says there's nothing to read, and once the buffer's full it says, oh, you can read, and you can read the whole lot out in one chunk, which is no good to us. We need that data to arrive at a steady rate. So you can go in here Come on. Set that to 64. Set, come on. That to 64. Actually, we don't transmit any, but we'll set it anyway. Hit OK there, OK there. And power up the Heresy software again. And it works. So that's quite annoying to have to do that every time Windows arbitrarily changes your COM port number. So there must be a better way, surely, and indeed there is. There is an FTDI API, so you can write directly to the FTDI drivers without going through Windows COM port interface. So I thought it's about time, since we use a lot of these little FTDI modules, it's about time we looked into that. Because I believe each of these FTDI modules has an ID, so you can just open the particular one you want. That one, in this case. Whatever has been plugged in wherever, and even if there's 2 or more FTDI modules plugged into the USB hub. So, without further ado, shall we dig into trying to get the FTDI working? FTDI API even. Okay, I'll save you hunting through. I did. So the programmer's guide is one thing we want, and there are some software examples which sound like something we could use, and they are just PDFs. So let's have a look at them. Okay, so here we have them. Well, we have them downloaded already. So let's look at the programmer's guide. And that, as we can see, just gives us a load of functions when we already have it, but we don't have it yet. It tells us we need FTD2XXDLL. Okay, and then it's into functions. Okay, so this is our example for Microsoft's Visual Studio, and this does actually tell us some useful stuff. So we need the FTD2XX.h header, and for the dynamic library we need those files for 32 or 64-bit, and for the static library we need those files. So let's see if we can locate those files somewhere. So there doesn't seem to be any documentation as to where all these driver and this include file are placed on your computer when you install it. So after a very lengthy search through the computer, I found versions in temp files and driver repositories, and indeed the Arduino IDE seemed to have downloaded a version, all of which seem to be dated about 2021. And if we look in the .h file, the copyright says 2001 to 2021, but there's no version information or anything on it. So your guess is as good as mine. So I have actually copied these files into an FTDI API folder, so I've got a copy. I know where I can find it. I've also generated a PC FTDI test folder, and in there I'm going to create a new project. So now I am just going to put a button and a memo on here so we can get it to do what we want it to do. Right, so what I am proposing to do is to create an FTDI class which will wrap up all the FTDI functionality that we actually want to use from the API, which has lots and lots of functions, most of which we don't need. Okay, so I've written a little bit of code that implements this scan function, which just calls the create device info list FTDI function, which just gives you the number of FTDI devices attached to the computer, and that's it. So let us compile that and see what happens. Okay, so we have unresolved external, which is what we would expect because we haven't told it where to look for our API function. So if we go back to our Visual Studio example, it says that we want the FTD2XX lib in the static library, and ours will be the i386, the 32-bit one. We also need to define FTD2XX static in our processor definitions. So shall we do that? Right, we need to be firstly in options, all configurations, all platforms, conditional defines, FTD2X static add, save, and we also need to add to our project this library file. Which is in static i386, any file, there's only one file in there, open, and there it is. Okay, shall we try again now and compile this? Oh dear. FTD2XX lib contains invalid OMF record type OX21, possibly cough. What does that mean? Okay, I googled that error and got this actually very useful post. Actually, you usually Google things and you get lots of not too useful posts to what I want. But this says, right, Borland, Embarcadero, etc. have an OMF file object for a library file, and Microsoft use a COFF format, COFF, and the two of course are incompatible. And can you convert them? Well, it says if the lib file is a static library instead of an import library, the situation becomes more convoluted. Oh good, you cannot link MSVC static libraries with the BCB project. You can't easily convert the library from COFF to OMF either. Borland's COFF to OMF tool only works with import libraries. So right, the .lib we want is an import library which talks to a DLL. There's a link to this in the description if you want to read it. So what we need to do is find the DLL and then use Borland's converter routines to convert them, and those converter routines are IMPLIB for 32-bit, and there is one for 64-bit which we'll look at anon. But let's just look at this for now. Here we have the relevant info for IMPLIB, implib. So I am going to knock together a little batch file and see if I can create a lib for our Borland file which will pick up our DLL. Okay, I put it in a little batch file just for ease of use. So IMPLib is options. Yep, don't know what any of those do, and I don't think I want to find out unless I have to. Next is lib name, so I've called it FTD2XX underscore BCB for the Borland Embarcadero C++ version. And next is just the DLL I want to make it out of. So shall we come into here? So here it is. Here is the DLL and here is my batch file. So we will run that. and it's worked. I thought it might not find the utility. Somebody must have set a path somewhere for us very kindly. Okay, so it's worked. It's done something. Let's not get ahead of ourselves here. And here we have our library. So if we go into here, let us just project. Well, run it won't. Okay, and it won't find our function, we know, because we haven't got a library. So let us grab our library, add. We should have that, that's the one we want, our modified lib. And there we go, that's in there. So shall we try again? Well, it's compiled, it's found it. So shall we hit scan? Oh, one. Right. Okay, so if I undo this and scan again, we get 0. Okay, so we've called create device info list, and that has told us how many devices we've got, and it internally creates a list of them, but to look at any of details of the devices we need to call get device info list, which will return a list. Well, we give it a pointer to a list of device list info node structures, and it will fill those in for us. So if we look at device info node, that contains some flags, a type, an ID, a local ID, a serial number, which is something we're interested in, a description, and a handle if we want to then open that particular device and read and write to it. So shall we implement that and see if we can get any information out of our FTDI chips? Okay, so we have no FTDIs connected as yet, so if we start up the software and we hit scan, we'll get 0. So let's first connect the one that will go on the boat speedo, connected to the GPS. It says so it is up and running. So if we scan, we've got 1, and if we hit list, we get some very interesting information. So flags, type, ID, local ID, a serial number which is specific to the chip, which is what we want, and the description is FD232R USB UART. So at least we know what we've got. Right, so if we now grab the heresy here, which is powered up, and we get another budlum which tells us Windows is happy with it. So if we hit scan again, we get 2 devices, and if we list those, there we go, and we get a different serial number. So we are going to now try and open, I think, the boat speedo device, and see if we can read whatever the GPS unit's putting out at the minute. Okay, so I have created a little open function for my FTDI class, and it calls FTOpenX. And that you can open with the name of the serial number of the FTDI, which is useful if we have one FTDI which runs one piece of software for what we're doing here. So wherever we plug the FTDI in, it'll look for that one with that serial number. And then it sets the baud rate to 9600. I don't know what the defaults are, but this is what I've found works. and it sets data characteristics to 8 bits, 1 stop bit, 8 data bits, 1 stop bit, and no parity. And then when it's done that, I've just got a timer which goes round and round, and if it's open it attempts to read a text buffer, and if it does read a text buffer successfully it prints it out. Nothing spectacular. So shall we have a look at that? Run. Okay, so we will scan, and then we've got the one plugged in, which is the boat speedometer one connected to the GPS, and here we have our serial number. So if we copy our serial number into this little box here and hit open read, there we go, we get a lot of GPS data. Which I will blur out, I'm afraid, just in case you try and figure out where our triplicate towers is located exactly. And here we have a close function which just calls ft close. Nothing difficult about that, so we will do that. And it says FTDI closed. And there we are, it's good to go. Okay, I think I am gonna call it a day on this video here. So we've enumerated and got data for our connected FTDI chips, and we've opened our FTDI chip and read from it and closed it again, which is pretty much all we want to do. I'm assuming the write is going to work okay as well, because it's a pretty simple function, and this API does lots of things, and you can write to the EEPROM and do all sorts of clever things, but maybe now I know how to do it I'll be inspired to do it, but for the minute all I want to do is read and write data out of an embedded processor. So that is it for this video. I am now waffling, so I will take my leave at this point and see you on the next one, where our projects will be talking directly to the FTDI, not through Windows COM port. So that's it for now from Triplicates. Goodbye.